class. Today we are going to be talking about when trigonometry is done on the coordinate plane but outside of the unit circle. So this first question asks, find the values of the 6 trig ratios for the angle created if a point -3, 4, so I'm just going to draw a -3 and 1, 2, 3, 4 lies on the terminal side. So that means that if we start rotating from the positive x-axis, like right here, and then we rotate that around, we're going to end up as my terminal side right there. Maybe I'll redraw that so it's straight. Okay. So I end right there, and again my point is -3, 4. So as we know, in order to find the trig ratios, we're going to find our right triangle. And again, it's called outside of the unit circle because the unit circle is just 1 unit long. It's this little tiny, the radius is 1 unit long. That's how big it is. So for these problems, we're going to be traveling outside the confines of the unit circle. But I can still use right triangular trigonometry. So I'm going to drop my vertical line to my x-axis. I'm going to note that I have a right angle right there, and then I'm going to label my sides. I went -3 in the x direction, which makes this -3 units. We know the length is 3, but the direction is negative, so we're going to label that -3. And we know the triangle has a height of 4 because the distance from the x-axis to that point is going to be 4 units, because that is how I got to the point. If we're looking at all the trig ratios, we're considering the angle that it makes right there with the origin. And we're going to need to find the hypotenuse. The hypotenuse is going to be found, we can use the Pythagorean theorem, or just remember 3, 4, 5 is a very common right triangle, our most popular one. So you can do a squared plus b squared equals c squared, or just know that if a is -3, b is 4, I'm going to find 5 for my hypotenuse. So if I do the sine of theta, we know it's opposite over hypotenuse. Opposite of this angle, if I go across my triangle, I get 4. So opposite of the triangle, I get 4, and the hypotenuse is 5. Right away, I'm going to do cosecant, which is the reciprocal of sine, h over o. So that's going to be 5/4. So I take care of those two right away. If I do cosine of theta, we know is adjacent over hypotenuse. So if I look at my angle, right here is my angle, there are actually 2 sides that make up that angle. In other words, are adjacent to that angle. It is the -3 side, and it's also the 5 side. It's both of those. However, the side that's 5 units long is the hypotenuse because it's across from that right angle. So the adjacent side is going to be -3, and the hypotenuse is 5. Then we can do the reciprocal trig ratio for cosine, that is secant. That's just flipping over cosine. That's going to be 5 over -3. And lastly, we can do our tangent ratios. We know tan of theta is opposite over adjacent. So if I go opposite this angle, I'm at 4. And adjacent to that angle, but not the hypotenuse, I'm at -3. So that is the tangent of that angle. Lastly, the reciprocal of the tangent function is cotangent. So that is a over o. All I have to do is flip that thing over. So here are all of my answers, all of the trig ratios that are made up if I am at -3, 4 on my coordinate plane. So here we have that theta lies in quadrant 4. Quadrant 4 is down here. And sine of theta is -12/13. So what I'm going to do, because I'm in quadrant 4, is really just draw a random angle in quadrant 4 right here. Label it theta. And then I'm going to go vertically to the x-axis to create a right triangle. Once I have my right triangle, I can label my right angle. I know sine theta is opposite over hypotenuse. So that means my opposite side is going to be at -12 and my hypotenuse is going to be at 13. I'm just taking that off the problem. So if I look at theta, opposite theta, which again I start at theta and I go opposite in the triangle, I should be at -12 right there. -12. -12, and then the hypotenuse is 13. So all I have to do is find this side that is missing. So to find the missing side, I can label that like A, for A squared equals B squared plus A squared plus B squared equals C squared. And I can use the Pythagorean theorem to solve for A. So A I'm trying to find. B squared, -12 squared. C squared, C is the hypotenuse, which is 13. So I get A squared plus 144 equals 169. All that's left to do is subtracting the 144 from both sides and then taking the square root. Normally, when I do the square root, I need plus minus, but in this case, it is going to be positive because when we look at this side, the x values are positive. We are in the first quadrant. So it's going to be A is +5. Okay. So that is the side. It's going to be 5 units long. If I want to get rid now of the A, I now know what it is, so I'm just going to label it as 5. Okay. So it says find the values of the other trig ratios. If I know sine, I know secant. Sorry, I know cosecant, because cosecant is the reciprocal of sine. So I can say cosecant of theta is just 13 over -12. So that's really, other than just restating sine, it's the easiest one to do. But I can also find cosine. Cosine is adjacent over hypotenuse. So if we look at this angle, the adjacent to that is not the hypotenuse, the one that makes up the angle, is that 5 right there. Again, there are two adjacent sides, but only one of them is not the hypotenuse. So adjacent over hypotenuse is 5 over 13. I know secant because it's the reciprocal of cosine. So far I have cosecant, I have cosine, I have secant. Now all I need are tangent and cotan. So we know tan theta is opposite over, oh, I should make a better A there, or better O there, opposite over adjacent. So if we look, here's my theta, opposite is going to be this -12 over the adjacent, which is 5, because again, adjacent means next to. So there's my tan. Lastly, my cotan is just the reciprocal of tan, 5 over negative 12. So again, this wouldn't be inside of a typical unit circle. Unit circle, the hypotenuse is 1. So I'm much bigger than a typical unit circle, but we can still use the concept of unit circle to solve these. Here we have theta lying in Q3, and cosine of theta is negative 3/5. So cosine, I'm in Q3, I'm going to draw a random angle in Q3, label that theta. When I make my right triangle, I always make it vertically with the x-axis. So I'm going to go up to my x-axis and draw my right triangle. We know cosine is adjacent over hypotenuse, which is negative 3 over 5. So that means when I look at this angle, I can label the right triangle hypotenuse as 5, and then the adjacent, again, adjacent means next to that angle theta, is negative 3. Now, we know we're familiar with our 3, 4, 5 right triangle, or I can use Pythagorean theorem. The thing I have to keep in mind is that this is not a positive 4. It is a negative 4. The reason it is negative is because when you look at this point, I go left for the x and down for the y. So the x value is negative, the y value is negative. So we could put a positive 4 or a negative 4. It's going to be negative because I'm going down to get to this point right here. So once I have my triangle, I can just find the other trig ratios. Because I know cosine, I know secant because they are reciprocals. So I get 5 over negative 3. We know sine of theta is opposite over hypotenuse. So when I look at my angle, I'm going to go opposite that angle to the other side of the triangle. I see my opposite side is at negative 4. We know our hypotenuse is 5. Our reciprocal to sine is cosecant. So all I have to do is flip that puppy over. Lastly, let's consider our tangent. Tan of theta, we know, is opposite over adjacent. So if I look at my angle and go opposite the angle, I know I'm at the side negative 4. And then the adjacent side is negative 3. I'm going to fix that fraction. We know a negative divided by a negative is a positive 4/3. That's tan of theta. If that's tan, I know cotan of theta is the reciprocal of that. So I have all that I need: sine, cosine, secant, cosecant, tangent, cotangent. So today we have a handout. This is it. And we'll just get some practice doing trigonometry, but not constrained to the unit circle.